Okay, I'm going to start with number 50 here. So give 5 examples of pure substances. For each, indicate whether it's an element or a compound. Alright, I'm just going to start listing some off. Iron element, aluminum element, nitrogen element, hydrogen element, helium element. There's 100 of those I could list. Those are all elements. Compounds are the other type of pure substance. So CO2 is a compound, NaCl is a compound, H2O is a compound, CH4 is a compound, NH3, that's ammonium, that's a compound, MgO, magnesium oxide, is a compound. You could list sugar, C6H12O6, that's glucose, that is a compound. 51. 2 examples of homogeneous mixtures. Mixtures where it's so evenly mixed you can't really see the particles. So sugar water, salt water. What else can I say? Any kind of like food dye in water is an example. You could say, it doesn't even have to be a liquid mixture. You could say things like steel is actually a homogeneous mixture. It's iron mixed with copper. Brass is another mixture. I believe it's copper mixed with zinc. I'm not 100% on that, but I know it is a mixture. So there's plenty of homogeneous mixtures. Air, good homogeneous mixture. It contains different gases, which we can't really see. Number 52, heterogeneous mixtures. Pond water is a good example because you could see the little pieces of dirt and mud floating around. Soil is a good example because you have dirt, you have rocks, you have plants, you have water. Sand is a good example because you can see all the little different chunks. Trail mix is a kind of a classic example. 53. 6 physical properties: malleability, ductility, color, magnetism, conductivity of heat, conductivity of electricity, melting point, boiling point, density, mass, volume, what else? Solubility, plenty of examples. 54. Chemical properties. Well, the ones we talked about were flammability and reactivity. Is boiling a physical change or a chemical change? Explain why. Boiling, like all of our phase changes, is a physical change, and that's because the atomic arrangement of the atoms does not change. If I have liquid water, it's still H2O. If I boil that into gaseous water, it's still H2O. So physical change. Name 2 other physical changes. Okay, well, I could give all 6 phase changes: freezing, melting, vaporizing, condensing, subliming, depositing. Okay, those are all physical. You could say cutting something in half. You could say dissolving something. You could say, what else? Smashing something with a hammer, see if it's malleable or not. These are all examples of physical changes. 57. 2 chemical changes. Electrolysis is an example of a chemical change. You're splitting up water. A chemical change is rusting. When rust occurs, it's a new substance. Tarnishing. When silver tarnishes, it's a new substance. Anytime you burn something, when you burn wood, you're making a new substance. When you burn or toast a marshmallow, you're making a new substance. When you cook something in the oven, like you throw all these ingredients into making bread, and the bread that comes out is a totally new substance. Digesting something is a physical change. Your body's breaking down all those little sugars and fats and turning it into other materials. 58. What's electrolysis? It's a process in which you run electricity through water, splits up the water into H2 gas and O2 gas. So you're breaking up a compound into its 2 elements. Chemical change. 59. Describe or sketch the difference between linear, branched, and cross-linked polymers. Linear, like this. Branched, you start with linear, you add branches to it. Cross-linked. Let me just continue this to make it cross-linked. cross-linked like that. Linear that are connected through other cross-links. Okay. 16. Rank the three types in order of strength and give a brief explanation of why. Well, the strongest is going to be cross-linked, and that's really because they're just held in both directions, like straight down and across. It's very strong. It's almost like rebar, which is underneath concrete. The next strongest is linear, and that's because if I have a whole bunch of linear polymers like this, I can compress them all together and make a really nice, tight polymer, linear polymer. And the weakest kind is branched, because if I have polymers with branches coming off like this, you can't really pack them together. It's going to be very low density, it's going to be weak, and it's going to be, again, not strong. 61. Give two examples of natural polymers. DNA, RNA, proteins, cell walls, skin, muscles, polysaccharides. Pretty much anything your body's made of is a polymer. Synthetic polymers, plastics, all plastics, polyethylene, which is plastic, bowling balls, bulletproof vest, which is Kevlar, Teflon, PVC pipe, what's it called? Teflon, I can't remember if I said that. Other types of synthetic polymers, car tires, that's a cross-linked polymer, vulcanized rubber. Plenty of examples. Water bottles, mostly just plastics. 63. What are the three particles that make up atoms? Protons, neutrons, and electrons. 64. What are the charges of these particles? Protons are positive, neutrons are neutral or no charge, and electrons are negative. 65. What are the relative sizes? Protons and neutrons are about the same size. Electrons are about 2,000 times smaller. Where are these located in the atom? Protons and neutrons are in the center. They make up what's called the nucleus, and the electrons orbit the nucleus. Should have made that one problem. All right, for the following three elements, identify the atomic number and the atomic mass. Okay, hydrogen. Atomic number is 1, and the atomic mass, I have this memorized, 1.00794, or 1.008. You just look at your periodic table. Fe is iron. Atomic number 26, atomic mass 55.847, and carbon, atomic number 6, atomic mass 12.011. What is atomic number? It's the number of protons. What is atomic mass? It's a number of protons. Oh, sorry, I was about to say mass number. That's, of course, the number of protons plus neutrons. Atomic mass is the average mass number of all the isotopes of an element. So it's the weighted average of how much each one weighs. So for carbon, it's 12.01. Well, that means that most carbon has a mass of about 12, which would be 6 protons, 6 neutrons. But a tiny percentage has a mass of more than 12. C14 is a very common, well, not a common isotope, but it's a well-known isotope. That's how we carbon date. So again, we have C12, we have C14. This is like 99.99%, and this is like 0.01%, but this tiny bit skews the number up a little bit, so the total atomic mass, 12.01. So it's the weighted average of the mass of the element. Number 70. Write the atomic notation for the following. O16 is going to look like this. O18 is going to look like this. Again, that's the atomic number. That's the mass number. Carbon with 6 neutrons is going to look like this. Well, carbon always has an atomic number of 6 protons. And if it also has 6 neutrons, that's your 12. Carbon with 8 neutrons, same 6 protons, but now it has 8, so that gives me 14. So that's my C12, C14. That's my O16, O18. I'll pause there.